I had the pleasure of undertaking my first professional practicum experience at Sadleir Public School, located in southwest Sydney. The My School website presents the following data for Sadleir Public School. Sadleir Public School prides itself in strong homeschool community partnerships and learning support systems that offer additional support for students with complex needs. Under the guidance of the School Excellence Framework, the school has also established a strategic improvement plan that aims to support the provision of high-quality educational opportunities. Students' work were displayed amongst the walls, with classroom rules, learning goals, and safety expectations presented at the front of the classroom. In this way, the classroom served to be a positive and welcoming learning environment which celebrated students' efforts and achievements. Students are given opportunities to work individually, in pairs, small groups, and as a whole class through the provision of flexible seating arrangements. A class dojo point initiative was also implemented in complementary to the Whole School Positive Behaviour for Learning initiative of Rocket Awards. This gave way to student ownership over their learning and behaviour. I spent my first practicum with K Orange, an early stage 1 kindergarten class. Students have a variety of academic, social, and emotional needs. Compared to previous kindergarten cohorts, K Orange demonstrated low achievement across all key learning areas, especially numeracy and literacy. Day-to-day learning was routine and structured, with literacy rotations and numeracy rotations taking place at the same time each day. Although students seemed to enjoy the learning activities, students were most likely on task than in task, engaging in the rotations for the sake of doing the work. These activities also had little evidence of problem solving and high-order thinking, despite addressing the learning content. iPads and the interactive whiteboard were also merely used to substitute other modes of learning or as a means of effective engagement and rewarding positive reinforcement. Ultimately, students were not deeply engaged and technology was not being used to its full potential in enhancing learning experiences in ways that drive substantive engagement. These limitations present me with the foundations of my research question. How can I meaningfully layer technology use in learning experiences that facilitate substantive engagement in mathematics? Based on the FairGo project, a motivation engagement framework, also known as the MEE framework, substantive engagement enables students to become better invested in their learning and engage in high-order thinking. By targeting high levels of cognitive, affective, and operative engagement, students will be given opportunities to think hard, feel good, and work to become better learners. Given the 21st century landscape, the affordances offered by purposeful technology integration in the modern classroom are undeniable in supporting students develop high-order skills necessary to respond to an increasingly volatile context. Technology integration also broadens teachers' potential in designing high-quality learning opportunities by expanding the traditional modes of teaching and learning. The aim of undertaking my action research is also established on the premise that deliberately engaging in an ongoing process of evaluation and critical reflection is necessary for the refinement of one's practices. By positioning myself as a researcher of my own practice, I embrace possibilities for action by viewing and analyzing my teaching and teaching context through a critical lens. Based on my findings of substantive engagement as well as the affordances offered by purposeful technology integration, I present 3 interconnected mathematics learning experiences. Across all 3 learning experiences, technology is integrated purposefully. Offered with the freedom to develop their own designs and presentations, students are invited to employ critical thinking skills, creativity, effective communication skills, and collaborative effort to interact with technology tools. With regard to high cognitive engagement, the learning experiences drive intellectual engagement with the curriculum content. For example, where problem-solving contexts are offered, students are expected to connect mathematical concepts to real-world contexts, engage in high-order thinking, provide critical reasoning for their decisions, and communicate their findings. Effective dimensions are targeted by planning enjoyable learning experiences that empower student agency and establishing links between curriculum content and students' everyday lives. For example, students are offered an opportunity to go outside and identify links between 2D shapes and the real-world environment. The Wixie app templates used in the third learning experience are also made relevant to students' lives. Students are able to find purpose in the tasks that they engage in. Operative engagement is addressed by incorporating technology in ways that expand the variety of learning experiences available. Students engage in screen-based technologies as resources that allow them to present their learning and findings. In this way, they build the independence and confidence to engage in lifelong learning. I will be using a combination of student work samples, records of observations, and learning conversations as data collection tools to review and evaluate the implemented changes and how this has led to improvement or lack thereof. Student work samples will be collected at the end of each lesson. For the first and third lesson, students will be assigned tasks through the Wixie iPad application, in which they will upload their storybooks and individual designs. In the second learning experience, students will need to take a screenshot of their designs. I will collect these screenshots at the end of the lesson and upload them to a USB, which will also store students' group storybooks and individual designs. In this way, all work samples collected across the mini unit of work will be stored in one place for later analysis. Contributions made by students during whole class discussions and conversations between students will be recorded on a trusted phone. Again, these recordings will be saved on a dedicated USB for later analysis. I've outlined opportunities for discussions and conversations between students that will be recorded across the 3 lessons. I've also listed some key areas that may be considered when recording student conversations, which will help during later analysis. Notes will be also taken based on observations of students during self-directed opportunities, where they are working individually or collaboratively in groups. As the class is quite small, all groups will be observed on a rotation basis of about 3 to 5 minutes each in the first lesson. There will be 2 rounds of observations. For individual observations during the second and third lesson, these will be about 1 to 2 minutes per student. Observations will be recorded on the table as displayed on this slide, which helps categorize links between students' displayed behavior and domains of student engagement as conceptualized by the MEE framework. Multiple data types will allow for a triangulation of insights that contribute to a comprehensive perspective of the effects of purposeful technology integration on engagement levels in mathematics. Markers of achievement are aligned to the relevant mathematics syllabus outcomes. Data will be analyzed based on the extent to which students have achieved the syllabus outcomes, specifically their ability to identify shapes in a range of contexts, sort shapes according to features, describe shapes, recognize and explain how shapes have been sorted, and the ability to represent shapes using technology. Similar to that of my observations template, I'll be compiling and categorizing data collected from work samples, observations, and conversations into relevant MEE engagement dimensions, which will then be further divided into whether the data demonstrates markers of engagement or disengagement. Although the classroom planning guide and observation and reflection guide drawn up by Munns and Sawyer was intended for classroom observations, I have adapted it for my data collection analysis as seen on this slide. A general summary will be established based on analyzing the compiled data to inform whether or not the pedagogic strategy resulted in changes in substantive engagement. This will be done for each lesson or activity. Each lesson or activity will also be analyzed in terms of whether opportunities for student self-assessment have been provided, a community of reflection was fostered, teacher initiative conversation was facilitated, and the extent to which teacher feedback was given. Both an analysis of the lesson or activity and the displayed behavior shown by students will work together to provide an in-depth account of which characteristics in teacher support have led to particular changes in substantive engagement. Displayed behavior will be categorized in terms of indicators of engagement. I have listed examples of markers of engagement and disengagement to provide an overview of how data collected will be interpreted. Considering the research on 21st century education and the MEE framework, purposeful technology integration can prove valuable in supporting student outcomes when it bolsters the provision of learning experiences characterized as high cognitive, high affective, and high operative. Initiating and carrying out action research has contributed to my professional development by holding me accountable for my teaching and offering opportunities to examine and inquire into my practices to bring about positive change and development. By enabling opportunities for critical self-reflection, I was able to interrogate my teaching, identify any gaps, and modify my teaching in response to these gaps, allowing me to meet many of the Australian professional standards for teachers as outlined by AITSL, including standards 6.2 and 6.4. Deepening my understanding on the value and implications of purposeful technology integration on students' learning through my action research, I have also addressed standards 1.2 and 3.6. While I have not necessarily carried out the design learning experiences, data collection, or analysis, I anticipate that constructive comments and feedback from colleagues during the course of action research will be used to support my professional learning in ways that align with Professional Standard 6.3. Hypothetically, the integration of technologies through my mini unit of work will support differentiation and support student participation by offering all students the opportunity to think hard, feel good, and work hard to become better learners, as summarized by Munns and Sawyers, in tune with standards 1.5 and 4.1. Ultimately, I've developed the confidence to incorporate technologies as well as other evidence-based pedagogical practices in my future teaching of mathematics that aim to enhance substantive engagement and strengthen motivation. My teaching practice has evolved to accommodate both the role of an educator as well as a researcher who delves into their own practice for the purpose of improvement and continually providing high-quality education for all students.